we're going to talk about radicals. A radical will undo exponents. So for instance, here we've got 2 squared equals 4. But then if you take the square root of 4, you'll get back to 2 that you started with. So both of these things actually mean the same thing. 2 squared equals 4 and the other one. Both of these are true statements, just that one is written in a radical form and the other one is written with exponents. Now this symbol that you see here, that is called a radical symbol, or radicand, sometimes it's called. Now, you usually have an index, which is a little number that you'll see inside. So for instance, this number right here, that's called an index, the little n that you see there. And if you have one that does not have a number in it like this, that means it's a square root. And so the index is automatically a little 2, but it might be a cube root like this one right here, or a 6th root, something else like that. So that's called an index, a little tiny number in there. Now, here's one thing that's important to note. If you have the even root of a negative number is not a real number. So for instance, that's going to apply to this first example that we have here. So whenever the index, the little number there, if that index is even and the number inside the radical is negative, that's not going to be a real number. It only happens when you have an even root and a negative number inside. So this here is not a real number. However, the one down below that we have here, the 4 through to 81, we will be able to get a real number for that. And that's because it's an even index, but the number inside the radical is positive. This means that we're able to do that. Now, if we look up at this definition of an nth root, we can change between the radical form and the exponent form by using that this property here. So if we apply that property to this example, this is going to tell us that 81 is equal to some number raised to the power of the index, raised to the 4th power. So if I can figure out what the b is, that's going to give me the answer for the whole thing. So the nth root of a is equal to b, but then if I write it this way, b raised to, so what number raised to the 4th power is going to give you 81. All right, so now if you're not sure, looking at this, what it is, okay, you can always do what's called a factor tree, where you're just writing down all the numbers or factors that multiply to make 81. So 81 is the same thing as 9 times 9, but we can break up each of these into 3 and 3. So we just keep breaking it down until we get to numbers that don't have any more factors. That's another word for that is prime numbers. So this here tells us that 81 is equal to 3 to the 4th power, because we see 4 3's multiplied together will give you 81. So this just means, since we found out what that number is, now we know what the 4th root of 81, the 4th root of 81, we now know is equal to 3. So that's how we find that one. Let's do another couple examples here. All right, so I have the cube root of negative 512. So what I have to do is negative 512 will be equal to some number raised to the 3rd power. I got to find out what that number is, and that's going to give me the answer for this problem. So I have to figure out numbers multiplied. Now, notice that the number inside is negative, okay? When I'm doing something like this with a cube, what it means is I'm actually multiplying 3 numbers together. And in order to make it negative, that means that these 3 numbers I multiply together would have to be negative. The reason why is because negative times a negative is positive. Positive times a negative is negative. So I know that whatever number I have that goes in here, it's got to be negative in order to get a negative inside. Now, you might be thinking, well, wait, didn't you say that if I have a negative number inside, it's going to be not a real number? Well, that's only if the index is even. Okay, now in this case, the index is odd. It's a 3. So we are able to actually do this and get an answer. That's why it is. It just so happens that the number we get is going to have to be negative, though, because we're multiplying it 3 times. All right. So if you're not sure what this is, you could always try a couple numbers on the calculator to see if it works. So maybe I'll start with a 5, for instance. If I use a calculator with that, I get 125. Then I'll try 6 cubed, 216, 7 cubed, 343, 8 cubed. That does give me 512. So I know that 8 is the number that I need to use here, but it's going to have to be negative. So I would know that the cube root of negative 512 is going to be equal to negative 8. And that's because negative 8 cubed is going to give me negative 512. We found that out by putting numbers in the calculator, and then from negatives, we know that all three would have to be negative there. Now this one, we want to do a cube root of 216. Now we've already did this one above when we worked with our calculator. We found that 6 to the third power is equal to 216. So I know that 216 is equal to 6 cubed. Therefore, the cube root of 216 is going to have to be equal to 6. All right, so you have something cubed, and if you take the cube root, you get back to the same base, the same number that you started with. And so 6 would be the answer for this one.